It should be. This is 4th class of 12 mathematics. Today we discuss about the transpose of matrices. Transpose of matrices in which matrices be transfer row to column. That means if 2 row and 3 columns, it change 3 row to 2 columns. It's if double transpose of the matrices, it becomes the same. If sum of the two matrices and transpose it, that is equal to sum of the transpose of two matrices, a scalar multiple of a matrices B transpose, that is same as the transpose matrices into a scalar multiple. If multiply two matrices B transpose, then equal to transpose multiple of the transpose of two matrices. In these cases, you follow the rule of addition and rule of multiplication. Suppose that you take the you have two matrices A and B of order 2 into 3 and 2 into 3. Sum of the matrices be this, and transpose of that matrices become the 2, 5, 1, 4, 1, 4. Now, after transpose of the matrices, both and add the matrices, its result be same as the given matrices. Now, transpose of matrices be two types. One of the symmetric and other is skew symmetric. Symmetric matrices means if transpose of matrices give the same matrices, that is called symmetric matrices. When transpose of matrices give the result of negative of that matrices, that is called skew symmetric matrices. Now you see here, addition of matrices and transpose of matrices, the result be symmetric matrices, and subtract the transpose of matrices in the matrices, it become the skew symmetric matrices, and its property, sum of the symmetric and skew symmetric matrices, sum of the symmetric and skew symmetric matrices, that is same as the matrices. You take one of the example. You have one of the matrices A 3, 5, 1, minus 1. One of the matrices. Now you form one of the matrices A plus A transpose of matrices. A means 3, 5, 1, minus 1. 1 plus 3, 5, 1 minus 1. This form of matrices, transpose of that matrices, you add the matrices, it becomes 6, 6, 6 and minus 2. Now, transpose of P, it becomes the 6, 6, 6 minus 2. It is similar to same as the P. That means it is symmetric matrices. Symmetric matrices. Now other hand, you take the matrices, subtract it, transpose of matrices 3, 5, 3, 5, 1, minus 1, 3, 5, 1, minus 1. Now transpose the matrices 3, 5, 1, minus 1. It becomes 6, 5 minus 1, 3 minus 3, 0, 5 minus 1, 4, 1 minus 5, minus 4, and it becomes 0. Now, transpose of Q, that will be 0, 4, minus 4, 0, and you take the common of a scalar multiple 0, 0, minus 4, 4, 0, and take the scalar multiple minus 1, that become the 0 minus 4, 4, 0, and the same result is Q. That is SQ symmetric matrices. Now P is the symmetric matrices and Q is the SQ symmetric matrices. If you add the both P plus Q, half P plus Q, half P, your P is the 6 minus 2, and Q 0, 4 minus 4, 0, 1 by 2, 6, 4, 10, 6 minus 4, 2, 6 minus 4, 2, minus 2, 0, minus 2, and divide by the 2, it becomes the 3, 5, 1, minus 1. That is same matrices. You see here, that will be same matrices of A. That means sum of the symmetric and skew symmetric, it become the matrices. Now, one of the example of the properties A 3A cos alpha sin alpha minus sin alpha cos alpha. If you A multiply with the transpose of the matrices, it become cos alpha sin alpha minus sin alpha cos alpha sin alpha minus sin alpha cos alpha. If you multiply both the matrices, you find the result that is same as the transpose of matrices A to A, that means identity. Thus you discussed in previous topics, you follow the rule of the multiplication and addition. You find you can solve the problem of transpose of matrices. Now you have solved NCERT exercise 3 by these rules, and if you follows the rules, you solve all the problems. Thank you.